Good morning, Michael.
Good morning.
All right. I am going to start. You're the only one on. Well, maybe there's others. Well, let's see. Nope. I am going to get started up in just a second. Let's see. All right. Okay, so I'm going to get started right now. As mentioned here today, I'm going to be going over Chapter 12. Good morning, John. We're starting up right now on Chapter 12, and no, I have not had a chance to grade anything more. I'm hoping to do that tonight, or I was hoping to do that tonight, and now I found out what we do twice a year at Rankin is we have what are called advisory committee meetings. And in fall, we bring in people, prospective employers from the St. Louis and St. Charles County area, and we meet. Well, we also have in spring, we have what's called an alumni advisory committee where we take people who have graduated over the last 2 or 3 years from the program, and we have them get together, and we have basically a Microsoft Zoom or Teams meeting, like a Zoom-like meeting like we're having now. And we have all of them get together for a couple hours. I thought the meeting was tomorrow. I had originally been told it was tomorrow, so I invited some people for tomorrow, and now I found out it's tonight. So if I have time, I'm gonna continue to grade. When the stuff is graded, it'll immediately be put out onto Inside Rankin. So today, as it says, we're going to begin going over Chapter 12 of the Muroc text. I also emailed you from the actual Muroc text itself, in case you didn't have it, the Chapter 12 stuff. You may get a problem when you try to open that up. It has nothing to do with anything I did, but I'll just mention that when we get to that point. As it says here, if we finish with Chapter 12 today, tomorrow we're going to start on our own project that we're going to do from scratch. And we'll work on that probably most, if not all, of the period tomorrow. You're not going to become an expert on this stuff in a day or two. All right, but if you understand basically the concepts that are explained in Chapter 12 by the end of the week, we're in pretty good shape then. All right, again, remember there is no actual homework that's due this week. As it says, if you're behind on anything in chapters 1 to 11, you have until this Sunday at midnight to get it in. There will be a grade penalty depending on how late the work is. But any work that you turn in after Sunday, is, anything after Sunday that's not turned in goes down as a 0 in the grade book. All right, and I'm trying to be as fair with that as I possibly can. A few people had emailed me saying, there's just been so much homework. Well, then technically, if you're up to date, there's no homework this week. All right. So with that said, let's jump right into Chapter 12. All right. Now, this is the prelude to it, so it's the beginning of Section 3. And as they mentioned, we did a lot of stuff already in the first 11 chapters. Again, I'm not going to read it to you. It's all out there. But we've gone through everything from creating simple console apps to going in and writing if statements and switch statements and loops. And we've gotten into arrays, etc. So we've done a lot of different stuff. All right. And we've talked about classes, whether you realize it or not. We've worked with classes, but virtually every class we've worked with thus far has been a built-in C# class. As it says, the chapters in sections 12 through 16 are going to show you how to create your own classes. So this current chapter that we're about to start or embark upon, Chapter 12, as mentioned, shows the basics of creating classes. Chapter 13 expands on that, as it says, and it'll go over some advanced features. This Chapter 13 is probably going to be pretty hard for you to understand much of the stuff that's in there. You will be tested on Chapter 12, all right? which is going to be, sometime probably next week, I would guess, which is on class basics. We'll go over 13, but then we'll immediately jump into 14. And your test after that will be on 13 and 14, very, very heavy on 14 with just a little smattering of 13. Then we'll go over 15 and 16, and you'll have a test on that. That'll get us through the stuff that we're working on for object-oriented programming. I'm not going to read the stuff that's in there. You can take a look at it. All right. So with that said, I'm going to jump right into chapter 12. Now, saying that, I want to mention something, and that is, I said yesterday, this is 50 pages, and we're not going to hurry our way through it. I am counting on those of you who are watching this live, so to speak, that when you have questions, you're going to ask. Also, for those watching this on video, if you've got questions, you're going to email me and ask them. This is probably the hardest thing that we'll have gone over up until this point. Many people who have taken this class have told me they think this is harder than what we go over next, which will be link and files, and it's also harder than databases. All right? And it's not a contest or anything, but just so you know. So as mentioned there, this chapter presents the basics of working with classes. All right, so as you can see, we'll get an intro into classes, talk about some skills for creating a class. Then we're going to go over this product maintenance application. This is the one I've sent to you. Then some more skills for creating a class. All right, talk about how to browse, display, and edit classes inside of Visual Studio. And then the chapter ends with working with structures and records. That's the last 7 or 8 pages of the chapter. I will go over structures. I will go over records with you. I can tell you there will be nothing on the hands-on test with structures or records. All right, I'll just leave it at that for right now. All right, the good thing or bad thing, depending on your point of view, when we start going through this stuff, just so you're aware of it, let me double check here and make sure that indeed I am taping. But the good thing, just so you know, yes, you're recording, good. All right. Is there are multiple ways of doing this same thing. And you might say, well, yeah, you always say that. Yeah, that's true. But even when you're creating the stuff that goes into a class, there's different ways that you can set it up. And good, bad, or indifferent, this book tries to show you as many of those ways as possible. So I'm going to go through those. Yeah, I'm going to show you those. But with that said, all right, with that said, when we start working on a class project tomorrow, when I say class, I mean we're going to be doing this as a class. It'll be a class project using classes. But when we do that, I'm not going to sit there and say, hey, now we can do it this way, and we can do it this way, and we can do it this way. I'm going to pick what I consider to be the easiest, most intuitive way, and that's the way that we're going to use, just so you're aware of that. All right, I'm going to, as I always do, kind of bounce back and forth between the page that's on the left-hand side, which is the even number page, which is all text, and what's on the right side, all right, the odd number page, which is typically code or pictures or explanations. All right, and what I don't want to do in here is I don't want to sit and read to you. You can all do that yourselves. Now, the first thing they talk about in here are multi-layered architectures. And the idea behind this is that you take the logic of the program and you separate it out into different pieces, or what they call layers. There are many different ways of doing this. They talk about a 3-layered architecture, and I'll talk about what they mention in here. All right, but I'm also going to mention another architecture. It's pretty much the same thing, but it goes by a different name, and we'll get to that in just a moment. So what they're saying here is with this 3-layered architecture, all right, you got to look at it that kind of it's going from the most outward thing, so the thing you see, to the most inward thing. So more or less from the person to the machine almost. So when you look at this in 3 layers, the first layer is the stuff we've been doing so far. It's the forms we've been creating. It's the console apps that we've been creating. And I want to show you something on that just so you know, because sometimes people start to get sort of an aha moment when they hear this. And that is, this is the code for Chapter 12 right here. Now, the reason I'm telling you that is there are three classes in here: product and program. Product and product DB and validator. Class files themselves are not GUI. I want everybody to hear that. Class files themselves are just code. So you say, oh, they're console applications. No, they're not an application. They are C# files, so .cs files that can be used in either a console application or in a GUI application. But when you look here, you'll notice, what do we have? So that's this one, there's this one, and there's this one. Well, notice that unlike forums, it doesn't have a resx file, etc., because they are not form files. That said, the form files are able to use the information that's in class files. That's what we're going to be getting into right now. So with this presentation layer, as it says, the stuff that's in there directly, that's the stuff we've been working with so far. We've been working solely with a presentation layer. We've been using our own form class that we've been creating. And whether you realize it or not, anytime that we've created an application, so if I go back to this and I open up, for example, this new product, all right, you could all build that right now. I have no doubt that you could. It's not very much. What? 3 labels, 3 text boxes, and 2 buttons. But when we look at this, notice that what it says, class. Every class that we've done so far has had this public partial class with a name we gave it, and then a colon, and then form. And what that means is every class that we've created so far inherits from the form class. That's why we need this using statement, because there's things in the form class that we want to be able to do in our program. And you'll notice that if I take this statement and I comment it out, wow, what happens? Lots of errors. All right, and you get lots of errors because it needs the information that's in the system.windows.forms class, and that's what we're getting by adding this. All right, like I said, I'm just going to be bouncing back and forth, and if I sound a little flitty, I'm not trying to. But the presentation layer is what you show. So if you're creating an application for somebody, the presentation layer is what you show to the user. The middle layer are, as it says, are typically what are called the business classes. Those are the rules that you need to use in here. Now, so far, we haven't been doing this. We have not been creating 3-layered architectures. We have been creating a single layer architecture that's had just a presentation layer to it. So what would we put in this business class? Well, imagine, not hard, but imagine Rankin Technical College. All right. If you are going to Rankin Technical College, let's say that you start watching these videos every day, but you're not in this class. All right. Can you do that? Well, if you can find out where, some of these I've put out on YouTube, some of these I have not. But if you can find out the URL for this, or if you've got a person in the class who sends you the URL to this stuff, yeah, you can watch everything. But you won't get credit for taking the class. You won't get any college credit. Why? Because in order to get college credit, you have to pay for the class. Once you pay for the class, you become a member of the class, etc. Those are business rules that typically get put into business classes. All right. Now, typically when you're working on an application, so let's say that we were writing an application for registration at Rankin. You would want some way to permanently save what we're working on. So once a person signs up for a class at Rankin, all right, there's a record of it and they're able to get, to actually be a member of the class. That kind of stuff would be put in a database layer. So, I mean, that's a very high level description. And you know what? If somebody else listened to what I said, they may not totally agree with what I said. But if you want more than what I gave you, you can read this. It's not my intention to sit and read to you. They do mention a couple of advantages in here, so let's quickly go over them. The first one is shareability. So if we are creating, as I mentioned, an application for Rankin Technical College, all right, for their registration system, there's a pretty good chance we're not going to have one programmer do it. We're going to have multiple programmers do it. And you might have multiple people working on the database layer, multiple people working on the middle layer, and multiple people working on the presentation layer. All right, so separating this out like this makes it much easier to divvy up responsibilities. That's the first thing. Second, it allows for what's referred to as code reuse. So imagine for a second, and I've given this example before, so Michael, you probably have heard it. All right, so imagine just for a second that, I don't know, a new hotel opened up in Wentzville, Missouri, and they contacted me and said, hey, would your students be willing to write an application for us? You know, that basically would do registration and all the other good stuff that they'd want done. Could we do that? Yeah, it probably would take quite a while, but yes, you could do that. All right. So let's say that that happens and we get it done. All right. And now one of the things about this hotel is they oftentimes, they also rent cars from the hotel through Enterprise, let's just say. And Enterprise hears about this thing we built for this registration system we built for the hotel, and they say, you know what, we've got a registration system too. It's different, but yet there's a lot of commonality. You know, would you think of building a registration for us? Yes. So what we're doing is, when you're starting to create all of this stuff, what you do is you create it in a very generic way. And what I mean is, you start from a very general point of view and you work down to a very specific point of view. I have likened this in the past to writing an outline where you've got your Roman numeral 1 at the top, and then you've got your ABCs, and underneath there your 1, 2, 3s, and underneath there your ABCs, etc. So you're going from very general to very specific. So that's another thing that a 3-layer architecture allows you to do. The third one, as it says here, and it's not an issue for us, we're using our own machine, but again, if we were doing this for enterprise or for a hotel or something, as it says, we can run the different layers on different servers. All right, so we can try to get the fastest and best performance we possibly can. All right, so if you want more, give this a read. You know, will you need to know this for what we're doing? Technically, no. All right, but they are trying to give you an overview of what's going on in here. So I'm trying to do the same. All right, one of the things that we went over in class yesterday is when you create a C# class, typically that C# class, as it says, includes properties and methods. We looked at this yesterday. It can also include events. What are events? You already know what events are. When you click on a button in your program, you do what? You bring up that button's click event so you can put in code. All right. So as the author says throughout this book, you've seen examples of apps that work with built-in .NET classes. All right. We've also done a little bit, as they say in there, with constructors, but you might find that confusing. But the point is, now we're going to do our own stuff. So as they mention here, we're going to design our own classes with our own properties, our own methods, our own constructors, and our own events. So let's take a look at the first thing that they show in here. They say we're going to build a product class, and every product has three properties. The first property, as mentioned, is a string, and it's the property code. It could be just all numbers. It could be all letters, but probably it's a combination of letters and numbers. All right. Even if it was all numbers, you would make it a string, you would not make it a numeric field. Because again, the only time you should make a field a numeric field is when potentially it could be used in some kind of a calculation. All right, from there, we have a description property, which again, as you can see, is a description of the product. Finally, we have a price. The price is a decimal with the product's price. All right. We have a single method called getDisplayText, and you'll notice that it passes in a separator. And the separator is how you separate the different elements. So as they say there, you could set it to a tab, you could set it to a comma, you could set it to a new line. But what you want to do is you want to make sure there's some separation between code and description and price. And that's what this will do. It'll display them, but it'll put whatever separator we want in between each one. Finally, we have this thing called a constructor that we looked at yesterday. And this is what's typically called a parameterless constructor. In other words, nothing is being passed in. Since nothing is being passed in, it'll create a new project object with default values. What are those? We're going to look at them in a minute. But you can also call a constructor and pass in all three things: a string for the code, a string for the description, and a string for the price. All right. Now, before I go through and talk about these, let's kind of quickly go over here, and I'm going to go over to product.cs. This is what they're talking about in here. So I want to take 5 minutes or so and go over it. So this is a class file. Now, just so you see this, and you're going to see it later in the chapter, but let's suppose I wanted to create a new class in this program. I don't, but we're going to pretend for a moment that I did. So then you take your mouse and you click on the name right there. You don't need this, but you come in and you click on the name of the project, which in here is product maintenance. Then you right mouse click, you choose add, and you choose new item. And you'll notice when you do that, what's at the top is class. So we could add a new class that way. If we don't want to do it that way, we can also right mouse click on here, choose add, and notice that if we come down near the very bottom, what comes in here? Class. And if we click that, it brings this up so we can create a new class. That's the same thing as if we went in and right mouse clicked and chose add and chose new item and then chose class. All right, so there's two ways that you can do this. Now we're assuming that this has already been built. Notice that this is called product here and its name is product.cs. Should be the same name. We've got another one in here called product.db, and you'll notice there's product.db. We've got another one called Validator, and if you'll notice, that one's called Validator. All right, so when we look at this, these right here are what are referred to as our class's instance variables. So every time we create a new product, in an ideal world at least, each new product that we create will have its own code, will have its own description, will have its own price. I want to say that again. You'll notice that these are all private, okay? And there are 3 instance variables in here. I'll put a comment in and say instance variables. Now later we'll talk about static variables. All right, we don't have any in here, but the difference between instance variables and static variables is that instance variables belong to each object. So every time we create a product object, it will have its own code, its own description, and its own price. Static variables belong to the class, so each object shares those variables. We'll talk about those later. But these are our instance variables. Almost always, as it's shown right here, they're made private. All right, and you give them the particular type that they have, as is shown right here. All right, good. I want to make sure that everybody is in. All right, and we don't give them any default values, nothing. Then you'll notice we've got two constructors. So this is what I typically call either a parameterless, and it's also called a no arg constructor. What does that mean? It means it's a constructor with nothing in here. It doesn't mean this is empty. It means nothing is being passed into it. Since nothing is being passed into it, I want to show you quickly what happens, what C# automatically does, even though all we've done is this. Even though that's all we've done, C# actually does this. It comes in and it says code equals, typically this dot code equals the empty string, this dot description equals the empty string, and this dot price equals 0.00m. And the reason that it does that is those are the default values. So the default value for any string is the empty string. The default value for any numeric field is 0. So we don't even have to do this. If we have a parameterless constructor, that's all we need to do. But I just showed you exactly what happens when we do this. All right. Then we've got what I typically call, and this is not an official term, but I call this a full arg constructor. What does that mean? Well, if you look up here, we've got 3 instance variables. And if you look in here, we're passing in 3 variables. So we are accounting for all 3 of our arguments in our constructor. Hence the name I gave it, full arg constructor. So when we come in and we create a brand new product, we're not doing that in here. We're not creating a new product in here. But when we create a brand new product, we will pass in a code. That code that you see right there is this code that's right here. And we will copy it over to this dot code, which will put it in here. All right. And I guess I was a little off before when I did mine. I didn't make these capitalized, and I should have. Now, even that's confusing. It's like, wait a minute. Here they're in capital letters. Here they're in lowercase letters. Here they're in capital letters. Here they're in capital letters. Here they are. Why? Because that's the way the language set it up. They're not like that in other object-oriented programming languages that I know. But you've got to follow the rules if you want to set it up correctly. So this supposes, all right, that we want to add a brand new product. When do we want to add a brand new product? Well, if I go into this thing right here, this allows us to add in a new code and a new description and a new price. And notice if I double click on save, what is it doing? It's coming through here and it's checking, first of all, if our data is valid. All right, this should look kind of familiar to you. So it's saying, first of all, was there something present in the first text box? Was there something present in the second text box? Was there something present in the third text box? All right, and if there were no errors, all right, if there were no errors, we're going to return success. But if there were errors, then we'll have an error message that'll say something, and it'll be called entry error. The reason I'm telling you this is what we want to do is if we have put in valid stuff inside of, where are we? Each one of these boxes there, come on, where are we? Here. And we click save, we want to save this. That's what we're doing here. But what we're defining here is the interface that's going to allow us to put in stuff. What we're doing here is we're setting up the actual product itself. So what a class is basically is it's the methods and the data that are going to describe an object. So this is the methods, or these are the methods and data that are going to describe a product object. So again, in this, we're going to set it to default values. So that expects that when we create a new product, we're not passing anything in. So it'll just set it to all defaults. Here, it's expecting that when we do this, we are passing in a code, which is a string, a description, which is a string, and a price, which is a decimal. All right. So those are the arguments. These down here, remember from yesterday, these are referred to as our getters and our setters. So how do we do this? Well, look at this, because again, it's confusing. You say public string code with a capital C. Then inside of these curly braces right here, you put in your getter, which just says return what our current code is, and a setter. And setter uses this magical value that's called value. Where does this setter get that value code from? Well, once we come in and we put in a new product and it validates that code, that there was something in there, that becomes value. Once we put in something for description and the system can sit there and validate that there's something put in there, it becomes value. Once we put in something for price and it says, hey, that's a number, etc., it becomes value. The reason that's important is, notice, code equal value, description equal value, price equal value. So these are our three getters and setters. So here's our getter for code. Here's our setter for code. Whoops, our setter for code. I shouldn't have done that. Here is our getter for description. Here is our setter for description. Here is our getter for price. Here is our setter for price. Now, if you're thinking that sort of makes sense, but really not really, you're probably with everybody else. All right, like I said, this is looking at something totally new. All right, finally, the last thing we have in here is we've got this thing called get display text. Now, hopefully you can look at what I have in blue here and you can understand the fact that this is one method that has been overloaded. In other words, if we call get display text and we pass it nothing, it uses a comma and a blank space as a separator. All right. So it returns basically get display text with a comma. Now, what does that mean? Let's start all over again. If we call this one right there, all right, if we call this one, what's going to happen is it's automatically, or as my friend Doug used to say, automagically, it's going to set our separator to a comma and a space. That's what this does. After it does that and it sets these, it's going to call this one. So it's going to put in the code and a comma. All right, the price and a comma, then the description. So if we don't call it with a separator, it's going to use a comma for the separator. But we could change this. For instance, if we change this to that, then we'd have code followed by a tab, followed by price, followed by a tab, followed by description. Or we could come in and do this. Remember, if we're putting it into, if we're going to display it on screen in a text box, we'd have to do a \r\n. And if we were putting it into a label, it could just be \n. But in this case, it would say code followed by a new line, then on the next line, the price, and then a new line, meaning on the next line, it would have description. But we're told in here, it's just going to be a comma. All right. All right. Now that's a lot to throw at you. I get it. All right. There is never a way that you can do this lecture where it's like people get done and go, you know what, that totally 100% makes sense to me. And I totally get it. All right. This is a learning process. So what can you put inside of a class? I don't want to read these to you, but you can see them right there. The things you're going to use most often are properties and methods and constants. I mean, field is really a property, but that's, it's those. Yes, you'll have a constructor. You may or may not use delegates. We'll talk about that next week. You may or may not respond to events. I mean, typically there'll be some kind of an event you want to respond to. You may or may not use constants. You may or may not use indexers and operators. All right. So, as I said, continue to page through here and at least look at the page on the right and at least look at the text that's typically on the bottom of the page. I'm not going to read this stuff to you. Yesterday, when we went over those two PDFs, I defined object for you. I defined properties. I defined methods. I defined a class. I defined instantiation. I defined encapsulation. And I defined data hiding, which is typically what we call abstraction. So you've gone over this stuff already. All right. Now, I think personally, it's going to start making more sense to you tomorrow. And that's why I want us to go in and start on our own project. So you might say, well, that's fine. Why didn't we just do that today? That would have made more sense. No, it wouldn't. We are going through this chapter because it has an already completed project in it. And I thought it would make sense to show you something that's already completed and go through it step by step. All right, we're going to kind of parrot what's going on in here starting tomorrow. And when we do this tomorrow, again, I'm going to ask that you go in, you create a brand new project, etc., because that's what we're going to be doing. All right, so on the next page here, it's starting to show you, and this is the same thing I just brought up. All right, so you might say, well, why didn't you go to here? I wanted to show you what it looks like actually in Visual Studio. So as they mentioned, a class begins with a class statement. Must always begin with a class statement. So we've got public class product, and there's our statement. All right. These in here, now our author calls these fields. I have always referred to these as instance variables, because remember, when you create an instance of a class, that's an object. So each object will have these variables. So if I create 10 products, hopefully at least I'll have 10 different product codes, 10 different product descriptions, and possibly 10 different product prices. All right. So again, I call these instance variables and they call them fields. It's no biggie really one way or the other. All right. Then they say after the fields are the declarations for two different constructors. Remember, the constructor is what is automatically called whenever you create a new instance of the class. So whenever you instantiate, in this case, a new product object, it will either call this constructor if you pass nothing in the parentheses, or it'll call this constructor if you pass in 3 values. If you pass in anything that's like 1 or 2 as opposed to all 3, you'll get an error. You either have to pass in nothing or you have to pass in everything. I already showed you what happens when you pass in nothing. It'll say this dot code equals the empty string, this dot description equals the empty string rather, and this dot price equals 0. All right, and that's their default values. If you do this one, it's assuming you're passing in a string for the code, a string for the description, and and a decimal for the price. So it's taking those values you passed in here, and those are here, here, and here, and you're using them to set the values here, which are these values right here. Now again, as I mentioned previously, what makes this confusing is, well, sometimes we're using capital letters and sometimes we're not. I didn't write the rules, I'm just playing the game. All right. So then down below here again, we've got our getters and setters. You'll notice that a getter is just an accessor. It just returns a value. A setter is a mutator. It just sets a value. Now, what you're going to see a little bit later, just so you're aware of this, is it's possible for you to have a getter and not a setter. If you've got a getter and not a setter, that assumes you've already set the value of something. All right. You know, it's kind of like a constant, but if you have no setter and only a getter, then that particular property is read-only because you can get it, but you can't set it. And although it's very uncommon, you can have no getter, but just a setter. And that's what's called a write-only property. You don't see those very often because normally there's not a reason to use those. So this is the getter and setter for the code. This is the getter and setter for the description. This is the getter and setter for the price. So if you don't like my explanation, please read through here and take a look at what they showed in the book. If you find what they're saying easier to comprehend or to swallow, cool, no problem. I'm not at all offended. All right, then finally again at the bottom, and I already showed you this. Now we've only got this. We don't have what's in that. Notice again, the thing that I showed you had get display text and it was overridden. In other words, it was in there twice. But in the book here, because they're just starting off, there's only this one. There's just one with a separator in it. So that's the entire class in a nutshell. All right, and again, I'm not going to run through here and keep saying, hey, does that make sense? Because it may make little to no sense. All right, and I will tell you this, and I'm sorry if I sound like a dope or whatever, but if you don't get this and you refuse to read the book, I have really no sympathy for you. All right, because you're going to have to learn it, because we're going to have 3 tests on this stuff. You're going to have a test on 12. You're going to have a test on 13 and 14. You're going to have a test on 15 and 16. Not only that, when we get into 17 and 18 and we talk files and we talk link, we'll still be using classes. When we get into 19 through 22 and we're working with databases, we'll still be using classes. So what I'm telling you is this stuff is not about to go away. All right? All right. So here they go over what I went through with you yesterday. They show you how instantiation works. Now, they show you actually 4 different ways you can instantiate or create an object. All right, I'm going to go over all 4, but when we do it, probably we're only going to use one way. I'll explain what that way is, and I'll explain why we will do it that way in just a moment. All right, so they explain each one. Again, I don't want to read here, so let's look at what they have. All right, so here is one way of doing this. You can say product, that's our class name, product 1 and product 2. If we do this, we are creating 2 new products, but after that first line, they have nothing in them. Then we instantiate it down below. All right. Now, do you have to do it like this? Say product like this? No, you could have said the word product here. I wouldn't have done it in 3 lines like this. I would have said here, right there, product with a capital P, product 1 equal new product. Boom. Product 2 equal new product. But I want you to understand something. This is where it's got to start making some sense to you. This C#, that's the product code. This ASP MVC, that's the product code. This Murox C#, that's the description. This Murox ASP.NET MVC, that's the description. This 5950M is the price for that product. This 6150M is the price for that product. Now, when we do it and we actually come in and start instantiating our own things tomorrow, we're going to do it this way. And you might say, okay, why? Because that's the way it's done in most other languages. So if there's a strong parallel between doing it like this in this language and doing it in other languages, I think that's the route we should go down. All right. But you can also set this up like this. In this second one, this is setting up a brand new, spanking new product. And what's it doing there? Notice paren. So I'm going to back up for a second. That paren is going to call this constructor, which will set code to the empty string, description to the empty string, and price to 0. On the other hand, the other one that we just looked at, this one, these two products that are right here are going to call this constructor right there. And you'll notice, or maybe you've noticed, maybe you haven't, that with a little bit we've just looked at, we're not doing any validation. We're not making sure, what if we put a negative number in here or in here? All right. It would take right now because we're not doing any validation. We'll get to that in a bit. So if we do it this first way that's right here, we're going to end up calling the second constructor. If we do it this way, this will call the first constructor. Then you have to add the values piecemeal. So you use the name of the product, dot, and then the name of the property, like code or description or price. Now, what should happen if we do this, what should happen is the IntelliSense should kick in. Let's see if I'm right or wrong. So when I come through here, I'm just making this up. So don't let this bother you. I'm going to get rid of it right away. So I'm going to, for a second here, I'm going to take these 3 lines and I'm just going to comment them out. Why? Because I want to put them in again so I can see if the IntelliSense kicked in. So if I say this dot, all right, and you'll notice it's got code both in lowercase and in uppercase. That's pretty darn confusing. All right. So we'll have to rely upon doing it the right way. All right. That we put the capital in there. This right here, whatever we call this has to be the same name and the same case as what's here. All right. And like I said, you know, I have given this lecture before, probably a good half dozen to a dozen times, if not more. And I've had people say, you know, I got everything until we got to this point, and now I'm just totally screwed up. And I get it. That's why I've decided to go back and create my own project and walk through it with you, because I think then it'll make more sense. So that's 2 different ways that we can create it. Filling in all the values from the get-go, or filling in nothing and then filling in the values one at a time. There's also something that's fairly new that's called an object initializer. And you can see what that one looks like. All right. It looks very similar to what we did up here, except you don't have to say product1.code, product1.description, and product1.price. All right. Because it's saying here, these are, since it's in the curlies, these are all a product 1. So the product 1's code will be this, the description will be this, the price will be this, etc. So then they say these are 3 different ways here that you can declare and create an object in a single statement. All right. Now, this one right here, I don't ever use. This is almost brand new. We're in C#11, and this is from C#9. I was always taught to do it the first way. And I know the first way is the way you do it in virtually every other language I know. So what's the difference between something being explicitly typed and something being implicitly typed? All right, so what's the difference between explicit and implicit? If something is explicitly typed, you must let the system know the type of class you're working with. All right, and you must let it know on the left-hand side of an equal sign. If something is implicitly typed, you use the word var and you let the system figure out for you, oh, that's a product. All right. And C# is one of the few languages that I know of that allow you to do that. And the last way, again, in here is leaving off the product or the type of class and just saying new. So that's a fairly new innovation, no pun intended. I'm just going to do mine the first way. But you will see all three of them used in actual application code. All right. So again, some real gold in this description down here, which I'm not going to read to you. All right. But it's explaining exactly what was going on in what was above. All right. There's only one thing that I do want to say to you, and I want to go over this right here, this thing. So I'm going to leave that in gray. I'm surprised I could highlight all of it. Now, what we've been doing so far is we've been doing always stuff like this. So we've been saying stuff like int age equal 21, string name equals Jeff, bool is married equal false. All right, stuff like that. All right, so why am I telling you that? Because if you were to go into computer memory, and I don't know what memory looks like, you can see pictures of it in books, but nobody knows. It's inside of the computer. All right, let's assume for a second that at location 3456 in the computer, all right, so somewhere in there, this is in the memory of the computer. All right, so I'm trying to draw you this. I want the number 21. So what is the number 21? It'll be 0, 0, 0, 0, 1, 0, 1, 1. That's actually what's going to be stored in there for H. So how did I get that number? All right, you may or may not be aware of this. This is the number of ones that I have. All right, in fact, I showed it to you wrong. 1, 2, let's see, 1, 2, 1, 2, 4, 16. All right, it's 1, 2, that's it. All right, so this is the number of ones I have. So how many ones do I have? I've got 1, 1. Okay, all right, fine. This is the number of 2's that I have. You keep doubling. So how many 2's do I have here? I have 0. This is the number of 4's that I have. All right. And I've got 1, 4. This is the number of 16's that I have. And I've got one of those. So when I add these, there's 16 plus 4 plus 1. So what I'm trying to do is I'm showing you the machine language, the zeros and ones the computer understands. Everything that we put into a computer has got to be changed into these. And I think I've given you the right number. It's not really important. The important thing is I want you to understand that when you put in simple variable types like this, something like this, all right, that it puts the actual value in a location in memory, the actual value itself. On the other hand, when I come through here and I say my public class product, all right, and I start to put in stuff, I'm not going to write a whole class for you, but if I write in string code and I write string description and I write decimal price, all right, and then I'm just going to put in here ... because there's a bunch of other stuff. I don't care what that is. All right, this stuff does not go into computer memory. What goes into computer memory is an address, all right? And that's the address of where this is located in memory. All right, so what that actually has, so if I went out to 3456, it would give me some god-awful address like 4CAX456, something like that. And that would be the place in computer memory where this begins. Why am I telling you this? because these are what are known as reference types. They don't, in memory, it doesn't hold the value, it holds the address of where all the stuff is located. And the reason that that is important is it would be totally possible with a product, I could have 100 different things that I defined in there. All right. So what it needs is just like the beginning or a point of where it starts. And you might say, I don't get it. And guess what? You kind of do, because that's the same way arrays worked. All right. So in your book here, they say a class is a reference type. This means that the variable that's used to access the object is instantiated from a class contains the address and not the actual object itself. And that's what I'm trying to get across to you. All right. And then again, it might make very little sense. And if it does, sorry. All right. I'm presenting this to you in the best way I know how to present this to you. All right. All right. It says now you're ready to learn some extra skills. Number one, to create a user-defined class, you start by adding a class file. Guess what? I already showed you how to do that. And I showed you 2 ways of doing that. So to repeat those, if I want to add a new class to this project, I right mouse click on the name of my project and I choose add, and I can either go down to the very bottom or second from the bottom and choose class, and that brings this up. Or when I right mouse click on it, I can choose add new item. And the first one that comes up is class. It's bringing up the same dialog. All right. It's the add new item dialog. So it brings it up regardless of how I do it. So that's the first skill that they go over here. All right. Then they show you the starting code for the new class. And you'll notice that there are 3 using statements. This again is going to make everything available from what is in system. And system is a library of routines that's out on no pun intended, out on the system someplace. And then these are allowing us to use collections generic, and this is allowing us to use text. All right. Then in our namespace, so let's quickly look at this. Notice here it says namespace, product maintenance, class product. All right. Well, that doesn't look like what I showed you. In other words, we had here namespace, in fact it does, namespace, product maintenance, class product. So they're building this thing out a very, very, very little bit at a time. All right. So you put this in here, and this is the shell. This will hold everything for the class. So to add a new class to a project, I showed you 2 ways of doing this. As it says, when you complete that dialog box, it adds a new class file. That's a new .cs file. So that's why when you look in here, you see product.cs, you see productdb.cs, and you see validator.cs. This other file is what you get. That's our main. You get that with everything. We don't need to monkey with that one, and we shouldn't. All right. But the product and the product DB and the validator, those are all class files, meaning they're just code, meaning they're in a .cs file, meaning they have no GUI component to them. All right. The namespace and class blocks, they say, will automatically be added for you. So this will basically be set up like this. So if I changed in down here instead of product, I put hello, it would look like this, except it would say, you know, namespace, whatever I created, this is the name of my solution. All right, and this would say class hello. All right, so notice this says namespace product maintenance. And if I come up here, whoops, I'm sorry. If I come up here to my solution, the name of my solution is product maintenance right there. All right. How to code fields. It says the next figure is going to show you how to code the fields that we're going to use. A class can have two kinds of fields. We've talked about this a little bit yesterday, and let's talk about it some more. All right. Now, notice in here, okay, we have got three different kinds of fields that have been defined. The second one that's shown there, public decimal price, you will virtually never do. They're putting it in here to show you that you can do it, but I've never seen this in actual application code. They're going to show you a way that you can do this with public fields on this page. I would suggest never, ever doing it this way. I would suggest that whenever possible, we make our fields private, like the first example that's in there. Now, if you look at the last example that says public read-only, that's a read-only field, and what that means is that when we go down to the getters and setters, there'll be a getter, there'll be no setter. We've already set its value, and we have let the system know that it is read-only. And if that confuses you, we've worked with read-only text boxes before. And what can they do? They can hold values, but you can't click in them and change values. And that's kind of what we're saying here. So they give you an example here, and I would never do this myself, but they make a product class that everything is public. All right. And then when you do that, basically, you know, it ends up that this is a lot smaller. You don't need your getters and setters, basically. All right. And that's all I'm going to say about this one, because I don't recommend ever doing this. But they're just telling you that you can do that. Now, jumping back, in 9:15, we're taking our first break, just so you know. All right. When you declare a field, you should give it an access modifier. We've talked private. We've talked public. We'll go over the other two, which are protected and internal. We'll go over those in Chapter 14. So we don't care about those right now, just public and private. If something is public, it's accessible not only by the class, but by any other class. If something is private, it's only accessible within the class where it's defined. All right. Again, they talk about read-only. And we don't have any static fields in here. So every one of these fields, even though they're public, even though this is a crummy example, these are all class variables. It's just that they're all public. Again, that's all I'm going to say. I would not use these. All right. So how to code properties. This is how we put in our getters and our setters. All right. Now, fortunately or unfortunately, depending on your point of view, there are different ways of doing this. They all do the same thing, but you can do them in different ways. Now, if there's only one line of code like this and it's just a return and it's just this, what they show right here, you can do it like this. And I don't want to confuse you, but I want to show you something quickly before we take our break. So I'm going to put in their example, this example right here. And you might say, why are you doing that if it's in the book? Because I want to show you something. All right, so I'm going to put in here and I'll make it smaller, but I'm going to put in exactly what's in the book. So I'm going to put in here public string code, curly, get, and we could put this like they have it here where it says return code, and then the curly here, and set, and code, whoops, you always, for some reason, they always put a blank space in there, equal value. All right, you can do it like that. That's totally fine. All right, so why am I showing you this? Because I want to show you three different ways of doing this. Why? Because you're going to see all three, probably even in this book. So there's one way. Another way is we can put these things on their own line. Right? And a lot of times you'll see developers doing it like this. All right. Now, not to confuse you, but just so you know, there's yet another way. If these are just straight getters and setters, that's just doing a return, and then it's just doing this. All right. I believe, and we're going to see it in just a minute, I think I'm giving you the right syntax for it. We could have also then done it like this. Again, I believe I'm giving you the right syntax. If I'm wrong, I'll correct myself in a minute. But I think we can just say curly get set like that, and just put in that. Again, I may have given you the wrong syntax, and if I did, I'll fix it momentarily. All right, and of course that is the wrong syntax. I think you can do it like that. Again, my syntax may be wrong, but we'll look at it in just a minute. The reason I'm showing you all three of these is all three of them are actually used in this book and in other books and actually out in application code. All right. All right. There's read only, again, has a getter, has no setter. Okay. Here's something that sets a property value. What does that mean? Notice what side of the equal sign something is on. If product.code is on the left-hand side of an equal sign, it's being set. If product.code is on the right-hand side of an equal sign, it's a getter. So if it's on the left-hand side, it's being set, making it a setter. If it's on the right-hand side, it's being accessed or it's a getter. These are just things you're going to have to commit to memory. That's all I can tell you. All right. It says here, it's common to use the same name for the property and the instance variable, but to begin the property name with an uppercase letter and the instance variable with a lowercase letter. All right. So they're calling this, basically they're saying that the stuff that we're putting in here, they're putting a differentiation. All right. Then they show you the getter, then they show you the setter, and then they show you a read only. And I'm not saying to you, hey, does that totally make sense? Because it may make very little sense. All right, so that's how we put in our properties. Next is how we put in our methods. And we already talked about this. If we have two different things in here, so if we've got two different things, both say public string get display text, but if what's inside of the parentheses is different, then we've got what are called overloaded methods. There is the first, there is the second. So if you call this with a separator, it'll do this automatically for you. If you call this without a separator, it'll automatically put in a comma and a space and then call this one. And again, not saying, hey, does that make sense? You've got to read through it and you've got to try to play computer to see what's going on in here, for lack of better words. So as they say, you can declare it using public to prevent other classes from accessing it. You can use private. That's the difference between public and private. Accessibility. If you want it known to the world, it's public. If you want it only known to the class in which it's associated, it's private. Again, those are the only two we're working with at the current time. What goes in these parentheses, here or here, that's called the method signature. So when you overload a method, you've got the same type, public, all right, the same return type, string, the same name, get display text, but what's in the parentheses must be different. Must be different. So in here we've got a string, and here we've got nothing. We could do this again, but we couldn't put in string, which is the single thing, even if it had a different name. All the system looks at is, okay, here's get display text with a string, here's get display text with nothing. All right, so if I want to overload this, and you can overload something multiple times, more than two, but the signature, what goes in those parentheses, must be different every time. All right. And that's overloading right there. The IntelliSense will try to help you, but be real leery when you do this. All right? Because when you do that, the IntelliSense puts down its best guess, which may or may not be correct. Finally, the note on the bottom says, instead of using overloaded methods, you can apply or supply optional parameters. We're not going to look at that right now. So the clock on the wall says that it's 9:15. As always, I'm going to give you 10 minutes. All right, and please come back then at 9:26. We'll pick it up. Thanks. I'm going to go get a new water, so I'll be right back. All right, I guess we're back. And now we're jumping into the land of constructors. So as it says right here, by default, when you use the new keyword, it automatically, when you're creating a new object, it will automatically invoke a constructor. All right. And the constructor must be the same name as the name of the class, and the constructor can be overloaded. All right, so here we've got what? Two different constructors, technically three if you look at this one right here, but let's look at these two. This again is what I called a no arg or a parameterless constructor. Now, when we looked at the other one, it doesn't matter if you put the curlies on separate lines or you put them up here or whatever, it doesn't matter. But this will take product and it'll grab those three instance variables that we have, those being code, description, and price, and it will set them to their default values. And it's to their C# default values. So the C# default value for a string is the empty string, thereby code and description will both be set to the empty string. And the default C# value for a decimal is 0. So the cost will be set to 0. So that's if you invoke that constructor, meaning there's nothing passed into it. Here's a constructor which I call a full arg constructor because we're passing in all three parameters. So that code that you see right here, that's this code. The description that you see right here, that's this description. The price that you see right here, that's that price. And the ones that are this dot, those are the actual instance variables themselves that are going to be set. So when we look at this, here notice the statements that call these constructors. So this is invoking the constructor, in other words. All right, this is doing the invocation right here. So when we say product1 equal new product, it will invoke that constructor because there's nothing in the parens here and there's nothing in the parens here. When we do the second one and we say product2 equals new product, C#, Muroc C# and 5950, that will invoke this constructor. And again, it will set code equal to C#, description equal to Muroc C#, and price equal to 5950 decimal. This last one will invoke this. All right. So notice it's already calling something else. So it's saying product P equal product db.get product code. So that's going to grab whatever is in the text box that's called code of the product DB. It's going to grab that. All right. And it'll, based on that, it'll set up its code and its description and its price. So if that confuses you, look at it this way. In the first two cases, we're creating a new product from scratch. In the third case, we're grabbing something that we've already put into, all right, that's already on the system, and we're bringing that up and setting it that way. Again, here's the default values. I'm not going to read them again. All right, couple of rules here. Again, the name of the constructor must be the same as the name of the class. All right. To code a constructor with parameters, you code a data type. It's kind of the way we've been doing it all along. There's nothing different from what's in here to what we've been doing. Type, name, type, name, type, name. Okay. The name of the class followed by its parameter list form the signature. Each constructor must have a unique signature. So again, notice there's one signature, product paren. There's another signature, product with all this stuff, and there's another signature right there. So they are all set up and they're all different. If the constructor does not assign a value to an instance variable and it wasn't initialized, it's given a default. Those things, same things we just showed you. All right, now we have just talked about this and we have just looked at this. All right, so we have looked at non-static members. Now we'll look at static members. I gave you an example of a static member yesterday. When something is static, it is shared by the entire class. Not only that, you can call it without having to create an instance of a class. And you might think, I don't get that. Yes, you do, because we went through an example of it yesterday. In other words, if I come in here and I create a variable and I say int hello equals math.py. I don't know why I would do that, but I could. And hello will now have a value something like 3.14159. It goes out further than that, but I only know pi to 5 digits. All right. The point is, we don't have to create, this is calling the pi method of the math class, and it's passing nothing into it. Why am I telling you this? Because we didn't have to create a new instance of the math class in order to be able to do this. This is what's called a static method. It belongs to the math class itself, and each instance can use its own copy of it, but it's all using really the same copy of it. All right. So again, whereas what we've been looking at previously, what they call fields and what I've been calling instance variables, they belong to the object. Static things belong to the class. All right. So to create a static member, they mentioned there, you simply include the keyword static. All right. And you can make static methods. Why would you want to do that? Notice it says the static is present method validates that the value passed in isn't an empty string. Well, if I'm using is present and I want to call is present, for example, on all three of my product fields, if I want to call it on the code and on the description and on the price, well, if I want to do that for all objects, why should I write that for each object? Why can't I let them share it? So instead of saying private string, etc., here, right, we use this one. Private string is present. We say private static string is present. Now, since it's public and it's static, this can be used by every one of our instance variables. All right, they've got another one here where they're setting up a line end to be \n. Don't worry about that for now. It's not that big a thing. Again, if you don't like my descriptions, all right, then take a look at your own. That's totally fine. Now, it says since the validator class shown in this figure contains only static members, the keyword static is used to declare the entire class as being static. What does that mean? Well, let's go over to here and let's look at our validator. There it is. Notice it's not public class, it's public static class. And the methods in there are static and static and static and static and static. So they look very, very, very similar to what we've been doing with what we did before we were working with objects. But now, since this is a static class with static methods, these methods can be used and shared by all of our objects. All right. And that's what I'm trying to get across. I don't know how well I am, but that's what I'm trying to get across to you. All right. Now it says with C# 6.0 and later, you can refer to a static member of a class without naming the class. So you can say this as opposed to validator.isPresent. Now, the author says, although this simplifies the code, they recommend that you don't do it for two reasons. Number one, sometimes in other languages, you'll have to put that in there. All right. And number two, it makes it clear what class that static member actually belongs to. All right. So again, there's a lot of gold in here. There's a lot of really good information. The examples are pretty good. and the description below the examples are pretty good. So as it says here, a static member is a field or a property or a method that can be accessed without creating an instance of the class. We never create an instance in the program that we're looking at. We never create an instance of the validator class. We never create an instance of it, but we can just use it. So we can say validator dot. It's a shareable class. So it can be used by the product class and it can be used by the product DB class. All right. All right, so let's jump into now. This is what I've been showing you. This is the product maintenance application. All right, so as they say here, now that you've learned the basic skills, now that you've been introduced to the basic skills, the topics that follow present this product maintenance application that maintains a simple file of products. Let me run it for you. And I want to show you it in action, so to speak. All right. So I'm going to run the program and it immediately comes up and it shows what? It shows we have nothing right now. We have no products. So if I click add product, notice it brings up our add product dialog. So let me move this. I guess I can't move that one. But in here, I'm going to put in for our code. I'll use what they did, which was C#, Murox, C#, let's just say 6th edition. And we'll say that it's 5950M. All right. So notice now what's going to happen when I click save. There's nothing in here. All right. It says price must be a valid decimal, so we don't put the M in. All right. So boom. We just took everything that we put in here. We took everything that we put in and we just copied it over. Now, this is not a real database, but we will take this example and put it into a database when we get into Chapter 20. Now, if I want to delete a product, I can't just click delete. I've got to highlight the product and then click delete. Notice it comes up then with a message box that says, are you sure you want to delete this? And it even gives us the name. If I say yes, it's gone. So now this is empty again. If I click add product and put in something new, so let's put in here, I don't know, JS, Murox, JavaScript, 4th edition. And we'll say that it's $60. All right, and save. Now that's in there. And we add another product. So we'll put in here, I don't know, we'll put in the same one, C#, Murox, C#, 6th edition, and we'll say that that's $55.55. Save, and now we've got two things in there. So we're building up a products list. This thing right here is simulating us putting it into a database. The reason I'm telling you that is if you didn't notice before, the name of the other class, let me stop the run here, is product DB. That's short for product database. It's really just that we're putting it into a file. All right, now let's see, because I don't know. So I'm going to call the run is stopped. Let me bring it up again. Notice my names are in there. So they persisted. If you want information to persist after you stop your program run, there are two basic ways of doing it. You can either A, do what they did here and put the information into a file, or B, which we'll do starting in Chapter 19, and that is work with a database. All right, so let me exit and let me go back to our text here. All right. So it says, as you'll see, this app uses the 3 user-defined classes in addition to 2 form classes and the program class that starts the program by running the first form. Okay. So it says this figure will describe the application. There's 2 forms. The main form displays the list of the products in a list, or the list of products. They're stored in a file. They're separated by a tab, each one. and they're in a list box. As it says, there are also buttons on there to either add a new product or delete an existing product. If you click the Add Product button, it brings up the new product form. Again, in a dialog box where you can put that information in. Now, just so you're aware of this, if I do this again, I'm going to run it again. This isn't going to work. I'm going to click Add Product, and I'm going to click Save. And it says, code is a required field, description is a required field, price is a valid decimal value, or must be a valid decimal value. What it's doing is it's running the is present on each one of those. All right. So what if I come back in here and do this? What if I try to cheat? I'm going to hit the space bar, and I'm going to hit the space bar, and I'm going to hit enter. Now it actually took blank spaces in for those. So what they really should have done in here when they were checking to see if something is present and they're not currently doing, what they should have done, but they're not currently doing, all right, is when we check for all this stuff and we look in the Validator, all right, so when we're looking in here and we say the is present, and we say if value is equal to nothing, all right, that's what got passed in is that value. I believe if we change it to if value dot trim is equal to that. Let's see if that changes it. So I'm going to come back in here and I'm going to again click add. I'm going to just hit the space bar and the space bar. And now notice I get all of my error messages. And I'm not, don't get me wrong, I'm not putting myself on a pedestal. I'm just saying that what Muroc should have done in there is they should have checked for that, because that's an old trick to sit there and just put in a blank space. So by adding the dot trim, the existing dot trim method, we kept that from happening. All right. To delete a product, you select the product from the list and you click the delete. It gives you the message box that makes you confirm that you indeed wanted to do it. Why do they do that? They do that in case you accidentally highlighted the wrong one when you click delete. All right. It says it also shows how the tag properties are set. It says, as you'll see in a minute, the methods of the data validation use the tag. Guess what? We've already been doing that. So you know how to set tag and you know what it is. So in other words, if I come in here and I bring up the main product that's right here, and I click on code, I should be able to go to tag and there's code. If I go to description, there's description. If I go to price, there's price. All right, so it's all hopefully reinforcing stuff we've already been working with. All right. All right, so this is it running, but I already showed you a run. This is the tag stuff, and I already showed you that. So again, if you need a micro encapsulated version, you don't want to read the entire page on the left. Normally, they have a description. They'll show you some code or some pictures or both, and then they'll give you a description of what was on the previous page. All right. All right, the classes that are used by the product maintenance application. Guess what? You know this already. What do I mean? You know there's a product class, you know there's a product DB class, and you know there's a validator class. Those are the three classes rather that are used by the application. So as they mention here, the product class is the same as the one that they introduced at the beginning of the chapter. In other words, it has the three properties: the string for the code, the string for the description, and the decimal for the price. In addition, it has the single method, all right, that will put them basically in a nice looking format. It also has two constructors, one which is the Arc Constructor, which takes code, description, and price and initializes them to their default values, and one with all three, the full Arc Constructor that takes code to whatever you passed in, description to whatever you passed in, and price to whatever you passed in. Then we've got the product DB class. We haven't looked at that yet. We can in a moment. Notice it says it contains two methods. The first is called getProducts. What does getProducts do? It retrieves the entire list of products from the product file and it returns them into a list of products. Now, what's new there? The fact that it's returning them from or retrieving them from a file is new because we have not looked at files yet. The second one, save products, writes them out to a file. I believe the author said, hey, we want to show this an example of these classes here, and we want our data to persist. So either we have to introduce some file stuff, even though we haven't gone over files yet, or we have to introduce databases. And showing files as they do is much simpler. There's less work. So let's look at that product DB class. That's right here. You'll notice a little longer than the other one, 64 lines. The previous one, no, first one was bigger. All right, so we'll look at product DB. Notice again, same namespace, different name of a product, and also notice this is static. Why is that static? Because you got to kind of look at it this way. This is static, where this one right here is not static. Here is where we're changing information. We're adding new people, etc. All right, here is where we are displaying information. All right. Now, so what are we doing here? We're setting up the directory. So we're saying that we're going to save this to this folder. So C:, C# files. There should be a file in there called products.txt. Now I'm going to try something, and I might look foolish in a moment, but I'm going to try something here. And that is, I'm going to bring up a File Explorer window. All right, I'm going to shrink it way down, and I'm going to go to my C drive. And under my C drive, I'm going to go to my C# folder. And in there, I'm going to go to Files. And in there, I'm going to go to products.txt, and I'm going to open it with Notepad. And does that look familiar? That's what got written from this file. That's what's displaying on screen. The difference is when it displays on screen, it is replacing these pipe signs. All right, so this pipe sign with a space, this pipe sign with a space, this space with a tab, this space with a tab. Whoops, not that one. This space with a tab. All right, so it's looking more like this. Well, not like that. Like this. Come on, Jeff. Like that. All right. And then this should be moved over as well. Okay. So it's basically doing that. All right. It's prettying it up, whatever you want to call it. But the point is, we're building the file right here. So we're letting it know where the directory is, and we're letting it know the path, which is that directory we just set, followed by products.txt. And I'm not going to save that file, but I do want to show you one last thing about that. So I'm going to come back and close it. It'll say, do you want to save? No. But when you look at it, I'm not going to bring the file up again, but what I want you to see is this. Notice, come on, when it was created today at 9:38 a.m., about 10 minutes ago. All right. So when we come back in here, and we look at the products DB, so this is basically setting up the directory and the file so we can save them. This, we need to use a list of products because remember, product holds, all right, a product holds a code that's a string, a description that's a string, and a price that's a decimal. Since we've got two different data types, we can't use an array for this. We use a list. What kind of list? A product list. So when we call get products, all right, when we call get products, what does it say? If the directory doesn't exist, create it. That's why when we first ran this, it brought up that empty box because there was nothing in there. All right. And then this says create the object. So basically this is creating the text file for us. All right. And this is creating the list for us. This is allowing us, it's looking through and it says, hey, do a peek. As long as there's stuff in there, start filling everything up for us. All right. Then we've opened up what's called a file connection, close that connection. And I'm not saying does that make sense? It might not make a lot, but that's for our input file. This is for our output. So before we call this stream reader and text in, now we're calling stream writer and text out. And that's where we're writing it back out. All right, that's setting it up and this is writing it out. And then we close that connection. And again, whether you really understand that or don't, that's not that important. All right. If for some reason we do something similar to this, which I guess we probably will, we'll be going over it again. All right. So we talked about the product class. We talked about the product DB class, and what's left then is the validator class. Again, with 4 static methods that provide for different types of data validation. Is present, is decimal, all right, is within range, and I don't remember what the other one is, so we can quickly look. So is present, is decimal, is int, all right, and is within range. All right. So they're running through it again. You've already seen this earlier. This looks the same as what we saw before. So does this, so does this. There's nothing in there that's new because we already built the product class. This is the new product DB class that just has 2 methods in it. One to get existing products, one to save a new product. All right, or an updated product, I guess, but probably just a new one the way it's written. Then we've got the validator, which sets our defaults, our line ending, checks for the presence or absence of something, verifies that it's an integer, verifies that it's a decimal, verifies that it's within range. And it says here on the bottom, because you don't need to know how this works, the code isn't shown here. It says, please refer to Chapter 17 for 2 different versions of this class. What's Chapter 17? Here's a surprise. Chapter 17 is on files. So what I gave you is hopefully all we're going to need for this for now. All right? Okay. So the next several pages that are in here are going to present the code for this. I've already tried going over this code with you. So in other words, we already went over, let's see, this is the stuff that's in here. All right, let's just take a look at it. All right, so here we're setting up a brand new thing of products. We're initializing it to null, meaning there's nothing in it. This is in our product, so this is the form code. This is in our main form. It's in the load event. So what are we doing? We're getting all the existing products. So that's going out to that file. And this is filling them up into the list box. If there are no products, okay, there's nothing to display. So when it calls fill list box, we've got a for each loop, and that's just adding them to the list box. We haven't done much with list box, but remember that they work with an items collection, like the drop-down list that we've used. All right, and like the combo boxes, whatever you want to call them. And you can use items.add with radio buttons, and you can use them with checkboxes as well. This is our add button. So if we click add on that form, what do? Hey, this should make sense. This is instantiating a new product form. All right. And then we're telling it product equal get new product. If it's not null, what are we doing? We're adding everything. We're adding that to our products list, and then we're saving it, and then we're doing a fill list box. What does that mean? That means this. That means if I run the program, this is the code we're looking at right now. It's what built this. All right, so if I click add products, and I put in here 1, 2, 3, and I put in here a Muroc book. And I put in here $34.56, that as soon as I click save, it first called the save product function, then it called the fill list box to redraw it with a new product in it. And that's exactly what they're saying. All right. Then we've got the delete. Notice in here it says selected index. Now you know exactly what that means. If it's equal to -1, there's nothing in there. So in other words, I'm just going to come back in just so you see this. And if I run the program again, all right, if I run, let me run it, get rid of that. If I run the program again, it comes up and it's got all three of these in here. If I click on here and I click delete, yes. Delete, yes. And delete, yes. Now in this list box, the selected index is 0. I'm sorry, it's -1. There's nothing in there. So if I click delete, we could have put a message in there that could have checked and said you must have an item in here to delete. But even if I add something, all right, so if I come in here and I type in 123, hello, and $23. Now I've got something in there, but when I click delete, if it's not highlighted, nothing happens because technically I have not yet selected an index. Once I click here, now I've selected index 0, so it can ask me if I want to delete, and if I say yes, it's gone. All right. And then we've got our close button. Okay. So this is the code for the new product form. So this is the other form. So what are we doing? Get new product. That's telling it to show that dialog box that for the new form that they created previously, and this will return it. Okay, then we've got in here our save. We want to validate that everything was correct in here. What does that mean? We want to run is present on all the fields. All right, and if it came back that it was valid, then we've got a new product. So we'll add whatever was in the first text box, whatever was in the second text box, whatever was in the third text box. The first two we can add directly because they're strings. The third one we cannot add directly because it's a number, but remember, since we put it into a text box, it's put in as characters or a character string. So we've got to convert it to decimal. All right, this is doing the validation. This says if there are any error messages, show them to us. We do a plus equal here and not an equal. We could have 0 errors or 1 error or 2 errors or all 3 in error. All right. Then finally, again, here's the code for our validator class, and I already went over that with you. Now it says the code for the isInt32 and the isWithinRange methods isn't shown here because they're not used by the product application, maintenance application. We could add those. So I mentioned this to you before, and I want to say it again, that right now there are problems with this program in its current format. So I can come in here and I can put in some junk and some more junk, but I should be able to come in here and put in -100. And it took it, and that is not correct. All right. So we could have gone in there and actually checked that stuff in Validator and isWithinRange. But to do that, we would have probably added class constants that had a minimum price and a maximum price. Then inside of the isWithinRange, we could have checked in here. We are checking, but technically we're not passing anything in. We're not calling this method currently. All right. All right. So we're up to more skills for creating a class. We are about half done with the chapter. Actually, I guess a little more than that. The chapter's 50 pages and we've gone through about 30, just about. So more skills for creating a class. The first one talks about auto-implemented properties. That's what I showed you before. Remember this? Get set. So if we put this in I'm going to show you what I showed you before. If we put in this one, I'm going to use that one as an example. So what they're showing in the book with this get set, I'm amazed I put it in there, and I actually have it. In fact, it's even simpler than when I made it. This right here does exactly the same thing as this right here, but it's code brevity. Now, if in my get method, all right, all I want to do is return the code, that's fine. But what if in my set method, what if I wanted to come in here and do something like this? If I wanted to come in and say, if value is greater than or equal to min, and value is less than or equal to max. So in other words, we're doing a range check. All right. So if we come in here and do a range check, and if we say, if that's all the case, okay, then curly brace, code equal value, like that. All right. Else, I'll just keep it real simple. I'll say else code equal 0. I'm just making this up. What I'm trying to tell you though is if I want to do some processing in here, I can't use this. This is only with auto implemented methods if I want to do a return like this, and if in here I want to do the equivalent of saying code equal value. If as long as that's all I want to do, all right, as long as that's all I want to do, then doing it like this is just fine. All right. And that's why they're called auto implemented. So they show you a bunch of different ways, different combinations, etc., that you can use with these. All right. And if you go, you know what, that's really confusing, then don't use them. All right. It says if the get simply returns the value and the set simply assigns, you can create the auto implemented property. They have to both be real simple, basically. Then you can do this. All right. And they show you that you can, this is a get, but this is a set, but they're giving it a value. So there's different combinations and permutations of this stuff that you can use. I don't want to give you too much because it's already confusing enough. And now we're going to talk about expression-bodied properties and accessors, and it's going to get even more confusing. All right. So in their quest, in this language's quest to try to be all things to all people, they oftentimes give you multiple ways of doing the same thing. Here is yet another example. All right, so let me go to the next page here and let's look at it. What they're saying here is, all right, this right here, this is the same as this. Now, when you look at this, you're like, wait a minute, so this equal sign and an arrow replaces returns, and yes, it does. And Michael, for you, and if Clayton was here, and I would think he'd be agreeing, this is similar to when we used arrow functions in JavaScript last semester. It's virtually the same thing. So what they're saying is this is a fairly new innovation, so rather than doing it this way, you can do it this way. I'm going to recommend that you do it in the way that's the most intuitive to you. Yeah, there might be 6 or 7 or 8 or whatever number of ways of doing the same thing. But does that mean that, you know, I'm looking at this makes more sense to me than this does. This first one makes more sense to me than the second one does. All right. Why? Because I've always done it this way. And for legacy reasons, etc., they're not going to get rid of. There are literally millions, if not billions, of lines of code of this stuff out there. So when they create a new way of doing something, they're not going to come in and say, well, now you got to change everything you've got in there. It's not going to happen. It's never going to happen, in my opinion. All right. So more description. Again, if a property is read-only and simply returns the value of the expression, you can use that expression-bodied property. As it says, it's been around since C# 6.0, and you use the lambda operator. It's the same thing as with we call it an arrow function in JavaScript. All right. So you can use them either with setters or with getters. All right. In fact, I think you only use them with setters. Maybe I'm wrong. Let's see. I don't use them. All right. To code an expression, yes, you can use them with set as well. All right. It says you can use refactoring to create those. I'll let you read that yourselves. It involves you highlighting a line, doing like a control period, etc., to bring up the refactoring screen. All right. How to code expression-bodied methods and constructors. So again, they're saying that rather than creating a method that looks like this, you can use it with this arrow-like function. All right. And you can do the same thing with constructors. Now, I'm not going to use those. Even though they're newer, I'm going to do them the other way. And the reason I'm going to do them the other way is, again, twofold. Number one, historically, that's the way it's been done. And number two, that's more the way it's done in other programming languages. All right. All right. The next thing they talk about in here then is pattern matching. It says to simplify the way you test for object types, C# 7.0 introduced a feature called pattern matching. You can use this with an if statement as illustrated here. So let's look at it. All right. You're passing into this thing an object, and it's an object that you call O. All right. So this is checking if the type of O that you passed in is a product. All right. That's what it's saying. Now, why is that important? Not right now, but as your programs get more complex, you're going to be working possibly with scores of different objects. Not in this class, but if you leave here and you go to a place that's a C# programming shop, in other words, that's what they use, it's not at all hard to believe that they could have hundreds, if not even thousands, of different types of objects. So this allows you to go in and check to see if an object is of a certain type. All right. All right. It says in Chapter 5, you learned how to switch expressions, how to use switch expressions in place of switch statements. All right. Well, you can do that in here with properties as well, with something called property patterns. So what they're saying is that you can come in here and rather than doing the old bump and grind type of way that we've done it in the past with a switch and then cases, you can basically collapse that down so it looks like this. So this says if the category is .NET, all right, you're going to set the percentage to 10%. If it's Java, it'll be 20%. Web, it'll be 30%. Mainframe, 40%. All right. And then that's for products and for vendors, depending on the quantity, 20%, and the terms, 30. All right. And a default here, remember that's that discard operator, would be nothing. And if you go, that's confusing, don't use it. There is so much stuff. They're trying to give you the 35,000 foot view. So we're looking at this from an airplane. All right. And what? When you do that, if you've ever been up in a plane and you've looked at, when you pass bodies of water or you pass towns, etc., it looks a heck of a lot different than when you're maybe 200 or 300 feet from the ground. All right. All right. Generate code stubs. I'm on page 412 here. As it says, in addition to the skills you just learned for creating classes, you can use a feature of Visual Studio called Live Code Analysis to generate code stubs for classes and its members. What it'll do is it'll start building the equivalent of templates for you, all right, so that you can go in and have some code start to be pre-generated for you, for lack of better words. So it says in the figure that we'll look at in a minute, it says in the first screen, you can see how they declared a variable named product, all right, from a class named product. But it says because the product class didn't exist, Visual Studio marks it as a syntax error. Then if you highlight it, one of the quick actions that'll be in there will say, hey, should I build a class for you? So what they're saying is if you're a lazy coder, all right, so notice in here we don't have a product class. So what they're saying is, hey, do you want it to generate a class for us called product? And if you choose that, it'll make it for you. All right. So as it says, the live code analysis feature lets you generate code stubs for any undefined class. And the stub is just basically the name. All right. The access modifier, so public or private, the return type, the name, parentheses, and curly braces. All right. Okay, we're coming to the home stretch, believe it or not. I'm not saying we'll be done by 10:30, but it'll probably be fairly close. And this is enough to throw at you in one day that I'm not going to start on our project until tomorrow. So if we're done at 10:30, guess what? We're done at 10:30 today. All right. So how to browse, display, and edit classes. Okay, so how to browse the classes in a solution. The easiest way, it says, is to use the Solution Explorer. The solution is, so they give an example. Now they're using 2019, we're using 2022, but to my knowledge, at least, it still works the same way. All right. So what are they doing here? They're bringing stuff up. Let's see if we can do this or kind of mimic what they're doing here. So we bring up the code. Let's see. That's not doing anything. Maybe it's just these. You can see how often I use this stuff. All right, I know it does that. You can put your mouse over anything, but there must be something else you have to do. Let's take a quick look. All right, it says to display the members of the class, etc., you expand the C# file for the class and then expand the class. All right, then let's do that. There it is, right there. And I think you can click on one of those and it'll jump right to it in the code itself. All right, so we can do that for product. We can do that for product DB, which as you can see is much smaller. And we can do that for validator. So it's one way that you can iterate your way through classes. To display the class view window, you do view class view command. Let's look at that. View class view. All right, so there it is up here. So there's product maintenance. There's our forms. There's the product class, the base types, etc. And you can keep going down and down with this. All right. All right. So let's see. The peak definition and the go-to definition features, again, remember what peak is. P-E-E-K. It's a look ahead. So the idea is if I've got an empty list and I do a peak, it's going to return -1, showing me that there's nothing in the list of things I'm looking at. If there's one product in it, it should return 0 type of an idea. All right. So as they mention here, there is a peek that you can use again to iterate your way through here. So it says here, you can use the peek definition window to display and edit code for a member in another class from within the class that refers to it. So you can be in one class and you could play with the code in another class at the same time. To do this, as it says, you right mouse click on the member and you choose peek from the shortcut menu. I don't like doing this. There's nothing wrong with it. I don't mean to say that there is, but it's meant to be a time-saving feature. I find it, since I'm in one class and it's bringing up another class, I find it to be a confusing feature. Now, if you disagree with that, take a look at what they say in here and feel free to use it to your heart's content. There may be questions on this in the written test. I don't remember. All right. Okay. Now, last two things that are discussed in the chapter are structures and records. They look very similar to one another, but structures are a value type, which means they hold values, not like we just did with classes that hold addresses. All right. Records, on the other hand, is a reference type. Okay. Now, you may have heard of records, and when I say records, I don't mean LPs or albums, but you may have heard of records when we talk about a database. All right. So, for instance, if I have 20 students in a class and I've got information about each student, I would have 20 student records type of an idea. All right. So structures are fine if you're working with very little data. So they're going to show you a structure in here and how you set it up. Typically, it'll be like this. All right. That's a read-only one. But again, a structure can contain the same type of stuff that a class contains. All right. It cannot have an empty constructor. All right. But it's good if you're just trying to store a real little bit of data. So it's sort of like a mini class without being a class. Now, you might say, that's fine. Why would we use these? I believe the reason that these are available is other programming languages use structures a lot more than this language does. For instance, for many years, I taught not C#, but the C programming language. And C is non-object oriented. So if you wanted to do the equivalent of create objects in object-oriented programming, you use structures. All right. So they show you an example program in here that goes through how to use a structure. What you'll notice is it looks very similar to the way we did a bunch of the stuff when we were using classes. All right. And then finally, they talk about the same last couple pages in the chapter here, how to create and use a record. It says the syntax is similar to creating a class or a structure. A record can have all the same types as a class or a structure. Like classes, but unlike structures, structures don't support inheritance. Records do support inheritance. So you'll notice when you look at this, it's not going to look that different from what we looked at when we created the class, but instead of saying public class product, it's now public record product. Or the other one, which could have been public structure product, for example. So, like a class, a record is a reference type, so it holds an address. Unlike a class, like it says, it has an equals method that compares the values of properties. So it works like both a class and like a structure, is what they're saying here. All right. It says you can create a record that contains read-only properties by passing it a list of properties, but you can't use the object initializer that we looked at earlier in the chapter. But you can use the keyword with as they show up here. And that's it. So what I'd like you to do, is this homework? No. but I'd like you to make sure that by the time we get into class tomorrow, if need be, you go back and you look at this Object-Oriented Programming 1 that we went over and the Object-Oriented Programming 2 that we went over, and that you go back in and peruse your way through the chapter. If there's anything that you don't understand, feel free to ask when we start up tomorrow. But we are going to start right at the beginning of class, and we're going to start building one or more of our own examples. All right? Does anyone have any overall questions on anything that we went over today? Anyone? All right, so the lecture today was approximately 2 hours and 15 minutes long. I had no idea how long this was going to take, but we'll pick it up here tomorrow. All right, writing our own program that's going to use classes. I'll talk to you then. Have a good day.